For lesson 2 of the equations unit, we are going to look at one-step equations, but with multiplying and dividing. So the steps are just like the steps for adding and subtracting. It's just that we're going to be using multiplication and division instead. So our inverse operations or opposite operations that we're using, if you have multiplication in the problem, the opposite is going to be to divide. So division is the opposite, and the opposite of division is multiplication. So let's look at example 1. So number 1, we've got 14x equals 168. So again, first step should be to draw your line down the middle of the equal sign. Second thing we're looking for is which side, left or right, is our variable on. In this case, it's on the left side. Then we're looking at what operation is being done to the variable. So in this one, when you have a number right next to a variable, that means it's being multiplied by, so the opposite is to divide. Now that we are looking at thinking of things algebraically, writing things algebraically, we're trying to get away from using the division sign. So what we want to see you do is show division by using the fraction bar. So if x is being multiplied by 14, the opposite is to divide by 14 with this division bar here. And if I do that on the left, I need to do that on the right. Well, now we need to rewrite what's left over in our problem. So if we have 14 divided by 14, well, any number divided by itself is 1. So you could write 1x, because 14 divided by 14 is 1, equals 168 divided by 14 is 12. Or, using the identity property, anything times 1 is just itself. So you really could just write this as x equals 12. And just like we were doing before, we're going to go back and check our answer. So we're going to plug this back into the original problem. Again, remember, this is not 1412. It is 14 times 12 equals 168. Again, we've got our calculator to do that. What's 14 times 12? It's 168. We got the same answer, which means we did the problem correctly. Number 2, we have 35 equals x over 7. First step, draw the line down the middle. Then we're looking for which side has the variable, right or left. In this instance, it's on the right side. Now, we're asking ourselves which operation is being done to the variable. Remember, this fraction bar means division. So x is being divided by 7, which means we need to do the opposite, which is to multiply by 7. Well, I'm going to, for this one, kind of write it as a fraction. 7 is the same thing as 7 over 1. Okay? If I multiply the right side by 7, I need to do the left side by 7 as well. So now when we're thinking about what gets eliminated, well, on this side I'm going to do 7 times 35, which if I multiply, I should get 245. Okay? On the right side, if we're thinking about multiplication here, like a fraction, when you've got our diagonals, if they are the same number, they actually cancel each other out. So you'd be left with x over 1, which really is just x, because anything divided by 1 is itself. So you'd get 245 equals x. Well, let's go ahead and check and see if that is correct. So let's plug it in. We've got 35 on the left, and then we got 245 for x, so we're going to plug that in. 245 divided by 7. Let's use our calculator. Let's see if that worked. 245 divided by 7. We got 35, so that means I did it correctly. So that was 2 problems with whole numbers. Now let's look at a couple problems with decimals. So for number 3, we're going to do 84. equals 1.5 x. First step, as always, drawing the line down the equal sign. Looking at both sides, right and left. Which side has the variable? In this case, it is the right side. Whenever you have a number right next to a variable, that means it's being multiplied, so the opposite to undo it would be to divide. Again, we don't want to use the division side. We are showing the line as the fraction bar for division. If we use the division sign, we're going to ask you to correct it. So if we divide the right side by 1.5, we have to divide the left side by 1.5. Then we're going to see what we get. 84 divided by 1.5. If I use my calculator, it's going to give me 56. On the right side, any number divided by itself, whether it's 5 divided by 5, 10 divided by 5, or 1.5, in this case, divided by 1.5, cancels out to just 1. So you can write 1x, or, again, we know 1x is the same thing as just x. Well, let's go back, plug in, see if that works. So we've got 84 on the left equals 1.5 times x, which we are saying is 56. Let's see if we plug that into our calculator. 1.5 times 56, we get 84. Just as the problem says, that means we did it correctly. Moving on to number 4. 3 4/10 equals x over 5 7/10. So again, we don't want to use x for multiplication. We can use dots, but it can get confusing, especially in problems like this, because we've got decimals in here. So let's look at this. We're going to draw the line down the middle, and look where our variable is. In this case, it's on the right side of the equation. So again, we have this fraction bar, which means x is being divided by 5.7, so the opposite is to multiply by 5.7. If I multiply the right side by 5.7, I need to multiply the left side by 5.7. Now we're going to go ahead and simplify and rewrite our expression. 5 7/10 times 3 4/10 is going to give me 19 38/100. On the right side, these will cancel out, because if you divide something by a number, you do the opposite, you multiply, those opposite operations cancel out. If you want to think about it as over 1, it's like a fraction, those diagonals cancel out. So on the right side, we are left with just x. So let's go ahead and check our work. We've got 3 4/10 equals x over 5.7. Well, we're saying x is 19 38/100 divided by 5.7. That is hard to look at and just be able to say, oh, that's right. So I'm definitely plugging this one into my calculator. 19 38/100 divided by 5 7/10. I got 3.4, which is exactly what we were looking for. So that means I did it correctly. All right, number 5. So we've got 2/5 x equals 18. So we did whole numbers, we did decimals, now we're moving on to our favorite, which is fractions. So again, as always, step 1, draw the line through the equal sign. Next thing we're looking for, which side is our equation on, or our variable on? In this case, it's on the left side here. So we got to think about what operation is happening here. Sometimes people get confused because they're like, oh, there's a fraction. Fraction means division. Well, yes, within the fraction, this means 2 divided by 5, but the variable isn't involved in that division. When we really think about it, we have a number which is written right next to a variable, which means it's being multiplied. It's 2/5 times x. This is the only instance that I'm going to say that it's okay for you to show the division sign, because it can kind of get tricky if you try to use a fraction bar for division when we already have a fraction here. So if x is being multiplied by 2/5, the opposite is to divide by 2/5. If I divide the left side by 2/5, I need to divide the right side by 2/5. Couple things to think about here. So first off, on the left side, 2/5 divided by 2/5. Well, it can kind of look tricky. You can calculate it on the calculator here and say 2/5 divided by 2/5, and it's going to show you that that equals 1. And if you really think about it, it's any number divided by itself. If I do 8 divided by 8, I'm going to get 1. If I do 4 divided by 4, I'm going to get 1. So even though this is a fraction, 2/5 divided by 2/5, the same thing, it's going to cancel out to 1 and just be x on the left side. Okay, on the right side, we've got division of fractions. So when we divide fractions, we don't need common denominators, but we do need improper fractions. This number 18 is a whole number, so I need to make that into a fraction by writing it over 1. Now we've got two fractions that we can divide. When we divide, we keep it, switch it, flip it. So keep our first number of 18 over 1, switch it from division to multiplication, flip it from 2 over 5 to 5 over 2. Now we can look at our two diagonals here. So we've got 1 and 5 for one of the diagonals, and we've got 18 and 2 for the other diagonal. If we are simplifying, the 1 and 5 are prime. They only divide by 1. So 1 divided by 1 is 1. 5 divided by 1 is 5. But 18 and 2, their greatest common factor is 2. 18 divided by 2 is 9. 2 divided by 2 is 1. So now we can multiply across to get our final answer. 9 times 5 is 45 over 1. You can leave it like that, or we know that 45 over 1 is just 45. One more fraction problem, and then I'm going to move on to the U tries. So we have 3/4 x equals 1 and 1/6. So, again, draw your line down. The equal sign, look at the side that has the variable, which in this case is on the left side. Again, it looks confusing because fractions mean division, but the variable isn't in that fraction. So this means it's being multiplied. 3/4 times x. The opposite of multiplying is to divide. If I divide the left side by 3/4, I need to divide the right side by 3/4. Again, any number divided by itself is 1. So 3/4 divided by 3/4 cancels out to 1x. And then over here, we need to divide. But in order to divide, we need to have improper fractions. So 1 and 1/6. As an improper fraction, 1 times 6 is 6, plus 1 is 7. 6 divided by 3/4 is already a fraction. So when we are dividing, we need to keep it, switch it, flip it. So 7 over 6, we're keeping the same, switching it from division to multiplication, flipping it from 3 over 4 to 4 over 3. Now we've got the fractions, and we can look at our diagonals to see what can simplify. So I'm highlighting my two diagonals, and we're going to simplify here. On the left, 1x is just x. On the right side, 7 and 3 are both prime numbers, so they only divide by 1. 7 divided by 1 is 7. 3 divided by 1 is 3. For 6 and 4, their greatest common factor is 2. 6 divided by 2 is 3. 4 divided by 2 is 2. We've simplified. Now we can multiply across. 7 times 2 is 14 over 3 times 3 is 9. And I'm fine with you leaving your answer as an improper fraction.